Mars, that rusty red beacon, has captivated humanity for millennia. But while we've spent decades studying its surface in the warm embrace of the Martian day, a new frontier beckons: the Martian night. Scientists have begun to observe unusual atmospheric events and puzzling surface phenomena that only occur after the sun dips below the horizon. So, what exactly is happening on Mars after dark? Let's delve into the shadows and uncover the red planet's nighttime mysteries. As night falls on Mars, the planet's thin atmosphere begins to stir in ways that are both subtle and spectacular. Invisible to the naked eye, the air ripples with what scientists call gravity waves, not to be confused with gravitational waves that ripple through space-time. These atmospheric waves are born when air is forced upward by Mars' rugged terrain, its hills, cliffs, and crater rims, creating oscillations that ripple outward like waves in a pond. On Earth, similar waves form when wind flows over mountains, but our thick atmosphere quickly dampens them. Mars, however, plays by different rules. With a much thinner atmosphere and lower gravity, Mars allows these waves to grow, stretch, and climb to incredible heights. Some of these waves can tower higher than Mount Everest, spanning hundreds of kilometers across the sky. As they rise, they transport energy and momentum, shaping wind patterns and causing dramatic temperature shifts between atmospheric layers. These shifts can influence everything from daily weather to long-term climate cycles, acting as a kind of atmospheric heartbeat for the planet, but their impact doesn't stop there. These waves can also help drive atmospheric escape, pushing particles high enough to be lost to space forever. It's a delicate balance, a cosmic tug-of-war between gravity pulling down and wave energy pushing up, constantly reshaping the Martian sky. By studying these waves, scientists gain crucial insights into how Mars's atmosphere behaves, evolves, and interacts with solar radiation and space weather. These ghostly ripples are more than fleeting curiosities. They're fingerprints of the planet's dynamic past and clues to its uncertain future. And the more we observe, the more we realize. Mars is not a dead world, but a place where the air still dances with secrets waiting to be uncovered. After sunset, Mars emits a faint, ghostly light, its nightglow. This glow comes from a chemical reaction. During the day, sunlight splits carbon dioxide in the upper atmosphere. At night, oxygen atoms recombine into molecules, releasing energy as light, too faint for our eyes but visible to orbiting instruments. This glow isn't just beautiful, it's a scientific goldmine. By analyzing its intensity and patterns, scientists can map high-altitude winds and track atmospheric tides. It's like having a planet-wide weather balloon constantly reporting back. The nightglow also offers clues about how Mars is slowly losing its atmosphere to space. In the quiet of Martian night, this subtle glow tells the story of a planet still evolving. Mars is cold, but some places are colder than we ever expected. In fact, certain regions on the red planet reach temperatures so low, they defy what we thought was possible for a planet without a thick atmosphere. These are Martian cold traps, where temperatures plunge below -130 degrees Celsius, freezing carbon dioxide straight out of the air. These frigid zones act like natural freezers, locking away gases and possibly even ancient materials. Surprisingly, they're not just at the poles or deep craters, they show up in shallow basins and flat plains too. This challenges our assumptions about how temperature behaves on Mars and where ice might be hiding. Scientists have mapped these cold traps using orbiters equipped with thermal sensors, revealing a patchwork of icy microclimates scattered across the planet. Why? One reason is surface composition. Different materials absorb and release heat at different rates, creating localized temperature extremes. Dark dust heats up fast, creating air currents that pull cold air into low spots. Another factor, subsurface ice, plays a crucial role in this thermal dance. In some areas it lies close to the surface, radiating heat away quickly at night. This rapid cooling creates ideal conditions for frost to form and persist. These cold traps may preserve ancient ice and possibly organic molecules from billions of years ago. If so, they could offer a frozen archive of Mars' environmental history. They're like time capsules, holding clues to Mars' past climate and potential for life. Each icy patch could contain secrets from an era when Mars was warmer and wetter. Some scientists believe these regions could even preserve biosignatures, chemical hints of past microbial life, shielded from radiation by layers of frost and dust. For future explorers, they're both a challenge and a resource, harsh environments but rich in water ice. That ice could be harvested for drinking water, fuel, or even breathable air. Understanding them is vital for planning human missions. Knowing where ice is and how stable it is could determine where we land and how we survive. Mars hides its secrets in the coldest corners. These frozen zones are more than just scientific curiosities, they're keys to unlocking the planet's past and future. And those secrets could reshape our understanding of the Red Planet. Every discovery in these icy regions brings us closer to answering the age-old question, was Mars ever alive? Even in the stillness of night, Mars is anything but quiet. Its surface whispers stories of ancient climates, lost water, and perhaps long-extinct life. It's a world of extremes and possibilities, and in the deep freeze of Mars, the next great discovery may already be waiting. At night, Mars reveals delicate ghost-like clouds, fleeting signs of a hidden water cycle. These wisps drift silently across the sky, barely visible yet rich with meaning. They are not just atmospheric curiosities, they are messengers from a planet that once may have flowed with rivers and lakes. These clouds form from water ice and carbon dioxide, crystallizing onto dust particles as temperatures plummet. In the frigid Martian night, when the surface cools rapidly, moisture in the thin atmosphere condenses into ice, clinging to airborne dust like frost on a window pane. Water ice clouds form lower in the sky, while dry ice clouds float higher, adding layers to the Martian atmosphere. This stratification creates a complex vertical structure, revealing how temperature and pressure shape the sky above the red planet. But these clouds don't behave like Earth's. They lack the moisture-driven storms we know, yet they dance with their own rhythm, one dictated by Mars's unique climate and thin air. They swirl, pulse, and vanish in hours, driven by temperature shifts, dust, and atmospheric waves. These rapid changes offer a glimpse into the dynamic forces still at play on a seemingly quiet world. Studying them helps scientists track water vapor, heat flow, and weather patterns. Each observation adds a piece to the puzzle of Mars's climate system, helping us understand how the planet evolved and how it might change in the future. And they hint at a wetter past, when Mars may have had a thicker atmosphere and flowing water. These clouds could be the last echoes of a time when the planet was more Earth-like, with a climate capable of sustaining rivers, lakes, and perhaps even life. These clouds may have shaped ancient rivers and valleys. As they formed and dissipated, they may have contributed to precipitation or frost cycles that slowly carved the Martian surface over millennia. Even today, they whisper clues about Mars's climate and its potential to support life. Their presence suggests that water, though scarce, still plays a role in the Martian environment, perhaps hidden beneath the surface or locked in seasonal cycles. In the Martian night, every wisp of cloud tells a story of a planet that once may have breathed, flowed, and perhaps even dreamed of life. And as we trace these whispers of water, we inch closer to understanding Mars not just as a world of dust and rock, but as a world of memory and mystery. Meet Ingenuity, the tiny helicopter that defied the odds on Mars. It made history with the first powered flight on another planet, but its real test? Surviving the brutal Martian night. Temperatures dropped to -100 degrees Fahrenheit, threatening to freeze its electronics and drain its batteries. Ingenuity fights back with solar-powered heaters and high-efficiency insulation. Every day it charges up. Every night, it holds on. It's not just flying, it's gathering science. Sensors track temperature changes, helping scientists understand the Martian microclimate. This data reveals how heat moves across terrain and how fast the ground cools. Ingenuity is more than a machine, it's a pathfinder. Its survival teaches us how to build future tech for Mars. In the silence of the Martian night, it hums with purpose, a symbol of innovation, resilience, and what's possible. From glowing skies to freezing traps, the Martian night is full of wonder. We've seen waves ripple through the air, clouds whisper of water, and a tiny helicopter defy the cold. But this is just the beginning. Future missions will dive deeper, studying gravity waves, mapping hidden ice, and tracking every shift in the atmosphere. What was once darkness is now a frontier of discovery. Mars after dark isn't empty, it's alive with secrets, waiting to be uncovered.